This is AI Podcast. I'm Ethan Park, and today we're unpacking an ACL 2025 paper titled MetaTool. In one line, it shows how a language model can notice when it lacks the right tool, retrieve one from a large external library, and then use it, rather than pretending or being spoon-fed a fixed list.
Hi everyone, I'm Maya Chen. That sounds practical, so the model can admit it's missing something and go find it instead of forcing a call that doesn't help.
Exactly. The work is led by Shengqian and colleagues at Shanghai Jiaotong University. They frame the challenge as open-world function calling. In a closed world, you preload all the tools in the prompt. In the open world, the model decides when to search for a tool, which tool to fetch, and when not to call anything at all.
Right, because you can't pack thousands of APIs into one prompt and expect smooth performance. What did they actually build?
They present MetaTool, which to the model looks like a single function. Step 1, the model hypothesizes the kind of tool it needs and what parameters it expects. Step 2, MetaTool retrieves candidates from a large external library using text embeddings. Step 3, the model invokes the return tool or tools. There's also a deliberate no-call path, so the model can ask for missing details instead of making a spurious call.
That abstain move sounds small, but it probably cuts down on those awkward made-up function calls we sometimes see.
It does. The paper explicitly measures irrelevance detection, recognizing when calling any tool would be wrong, and MetaTool helps there. The team also releases a benchmark called MetaBench, built around multi-turn dialogues and a large tool catalog, so retrieval is genuinely non-trivial. The benchmark covers scenarios where a needed function is missing and must be retrieved, where a function already exists, multi-tool chains, and plain chat where no call should happen.
So the model has to do two things at once: find the right tool when it's missing and also know when to stay in chat mode. How do they evaluate models on this?
They track whether the model detects a missing function and triggers retrieval at the right time, whether it selects an appropriate tool from the retrieved set, whether the parameters make sense, and whether it avoids irrelevant calls. They compare a range of systems, including their fine-tuned model called MT-Llama, which is based on Llama 3.18b, alongside strong commercial and open baselines.
And how did it do, especially in tougher settings?
In the hardest function-missing cases, their fine-tuned model shows a clear improvement over strong baselines at noticing the absence of a needed function and initiating retrieval. It also maintains strong restraint in the scenarios where no tool should be called. The broader picture is that making the model hypothesize the tool first, then retrieve, leads to more reliable behavior than simple keyword or history-based retrieval.
Can you give a day-to-day example of open-world function calling just to ground it?
Imagine planning a trip. You ask about train times, then museum hours, then a dinner reservation. Instead of preloading every travel and booking API into the prompt, the model recognizes it needs a train schedule tool, retrieves it, uses it, and later retrieves a museum information tool, and so on. It decides when to search and what to fetch, step by step.
That makes sense. Why does their approach work better than simple retrieval?
Because the model doesn't retrieve blindly. It first writes down a short description of the tool it believes it needs and the parameters it expects, almost like a mini-spec. Retrieval then matches that hypothesis against the tool library, which makes the search more targeted. In ablations, explicitly prompting the model to reason before acting improve performance in the more complex multi-turn settings.
Got it. Any caveats we should keep in mind?
A few. The benchmark and training data come from similar sources, which raises the possibility of distribution proximity. The pipeline relies heavily on synthetic data and LLM-based verification, which is efficient, but can reflect the verifier's biases. The retrieval baselines are fairly standard, so it would be useful to compare against stronger hybrid or re-ranking stacks. and most metrics focus on retrieval and argument quality rather than full end-to-end task completion, like actually finishing a multi-API workflow in the wild.
That's fair. Do they share resources for others to try?
Yes, they release the benchmark, the code, and the fine-tuned weights. The idea is straightforward to plug into existing agents. Expose MetaTool as a function, let the model hypothesize what it needs, retrieve candidates, and only then execute.
If you were advising a team building agents right now, what would you suggest based on this paper?
Give your model a clear way to say, I need a tool like this, and retrieve from an external registry instead of stuffing everything into the prompt. Always include an abstain path so the model can ask for missing details. Encourage a reason-then-act format. Hypothesize, retrieve, and only then invoke.
And what would you like to see next from the research side?
I'd like to see stronger retrieval stacks, broader out-of-distribution tools and schemas, and evaluations that track real task success from start to finish. It would also be helpful to repeat the fine-tuning recipe on larger or different base models and tighten the separation between training and benchmark tools.
Nicely put. So the headline is that MetaTool helps models know when to call a tool, what to retrieve, and when to hold back, which makes tool use more robust in realistic, multi-turn conversations.
That's the takeaway. Thanks for listening. This has been AI Podcast.